web architectures, and we're going to talk a bit about Node.js. Mainly, we're going to have on one hand, a historical perspective, and on the other, we're going to just look at some pieces of code, which we're going to explain, and they're going to show us how stuff works in Node. Now, when talking about Node, we're talking about server-side JavaScript, and this is something I mentioned in the tutorial, which is that server-side JavaScript is going to differ from client-side JavaScript. On one hand, on the APIs I have accessible, and on the other, it's going to differ through the context in which I'm executing things. Because it's sufficient to think about accessing a window on the server or listing all the directories in the root of the computer I'm running in on the client. I can do neither of those things. For the client example, I shouldn't be able to do that, and the code should be run in a sandbox fashion. For the server, while I may obtain a window, it's not going to be something which is going to be trivial, right? It's going to be a non-trivial thing. Right, so we're talking about the same language, different APIs. Here, something to note is the fact that JavaScript actually has a standard which is somewhat dynamic, and it's unequally implemented, right? So I'm going to have features that are going to be present in one implementation and maybe not in the other. Now, the language itself allows for rapid development. It's what I like to call a short failure cycle, because when writing code, we're going to fail a lot and repeatedly until we get something which is successful. So it's oriented on this ease of development. Now, Node is easy to create. It makes it easy to create classic servers, or basic servers which are actually listening to a socket and answering client requests. We're going to see such a server. The trade-off here stems from two things. The servers themselves are going to be treated as something event-based. Right? They're not going to be treated at the same low level I would get in other languages. I can actually access the underlying socket, but I can't actually control it fully. On the other hand, if I'm writing something which is application level, I shouldn't generally need that, right? If I want to control how TCP/IP packets are constructed, probably Node would not be my best choice. I do it in something which is systems oriented, like C or C++. It's easy to create parallel tasks. This comes with its own trade-offs, though, because in Node, just like in JavaScript in the client, I'm going to have most long-running things are going to be run asynchronously. And this raises its own challenges, and we saw, or we'll see at the tutorial, the part about promises, right? And I'm going to need some sort of mechanism to be able to wait for the result of an asynchronous operation. Now, it does this by running, it does parallel tasks without actually running multiple threads. It runs a single thread, and it's going to be difficult for me to have access to threads. Right? Now, the fundamental Node mechanism is the fact that it runs on an event cycle. Obviously, the events are going to be different, and I'm going to have more events on the server. However, both on the client and on the server, I can create my own custom events. Events are handled by attaching the handler with an on method. And in order to showcase how everything works, let's just look at a relatively simple example of a Node server. And this is going to be the classic example of a chat server. Right. A chat server is going to receive some message from a user, and it's going to forward it to all other users. Let me just find it. Okay. Okay, so this is going to be a chat server. So I'm going to notice a few things about my Node application. First of all, this is my whole application, right? And I notice that I have two files. One of them concerns the JavaScript interpreter on the server, which is going to be Node. And it's going to be, I just pass some JavaScript to the interpreter and it runs it. and the other one is going to concern a secondary tool. It's something which is called the package JSON, and this should hint that it's going to contain the representation of an object in a manner really similar to JavaScript. Right? In this case, it's going to be something like that. Much of this stuff is just something which is a description of the project. However, what will concern me is this dependencies block. And this is actually, Node contains one of the most elegant mechanisms for this. Whenever I'm writing code which is fairly complex, I'm going to use at least some libraries written by other people. And when I use libraries written by other people, I run into a problem, which is dependency management. Imagine that you get some code, and the code depends on some libraries, and you can't straightforwardly identify which versions of those libraries you need. This will tend to become a nightmare in a very short period of time, because you have to identify their dependencies, and then the dependencies of the dependencies, and so forth. And Node actually gives me a really flexible mechanism, which is this Node package manager. And I can specify some dependencies, and my dependencies are going to specify the version. This actually insulates me from something which is a bit of a defect of the JavaScript ecosystem in itself, which is the fact that it's very rapidly evolving. And for example, some people write a library, and at some point they run into a revelation. They've written it wrong. And they're going to write it right? And they're going to write it right in such a fashion that it's not going to be compatible with previous code. And my problem as a developer is that I already have some code which is dependent on some version of that library. I can't rewrite it every time they have a revelation. This thing with package JSON is going to allow me to do that, because I'm going to have something like this. Now, these are with all versions. Let me just show you something more relevant. I'm going to have something like this, which is going to say, for the library body parser, I need at least version this. And if the guys have a revelation, I can just delete the little caret, and it's going to say exactly version 1.18.2. So I'm going to still have running code. The second advantage is that I'm going to, if I want to give my source code to somebody, I'm just going to give them the server, the actual code, and this package JSON. And they're going to be able to get all dependencies automatically and be able to run my code in something like under 5 minutes. This is not a good example, actually, because net is actually included in Node.js. I don't know why it's written there. Now, back to our code. This is our wonderful chat server. And if I look at the second line, I'm going to see that I do something which says require net. Now, this might seem something which is similar to an include or a using or an import, but it's actually something a bit different. Since in JavaScript most things are concrete, what require does is it returns an object which represents the library. So it's a concrete thing, right? I'm not getting access to a namespace. I'm actually getting a concrete object, which is the library. Now, this is a really simple server, so I say net create server, right? This is my server, and I have a list of clients. And the server is going to be able to respond to a series of events. Now let's, before discussing it further, let's just see it in action. I'm going to open a thing here. I think it's in Dropbox something. Okay, so it's v3. Right, and I can just run it like this. So it's interpreter server, and I get a server. Now, to demonstrate this, you should connect to it, and we're going to use Netcat, which is actually present by default in Linux. So my server is going to be localhost, and the port is going to be this. Okay, obviously a chat server is not going to make any sense without having somebody to talk to. So you're going to say hello. Right, and if we look in the other window, this happened. So I have an important message. So it's a minimalistic example. However, what it does support is graceful failure. So, for example, if I do this, nothing anomalous happens, right? Everything works still as expected. So let's see how it works. But what's going to happen is that the server is going to support an event which is going to be the connection event. Now, these events are contextual in the sense that the connection is going to make sense at the beginning. However, something like a connection end is only going to make sense if I'm already connected. Now, the way I'm going to handle it is that I'm going to have an event handler, which in this case is going to be a function of client. Whenever somebody connects, I get an object which allows me to interact with them. So I'm going to save the client in my list of clients, which is a regular array. It's nothing special. And then I'm going to handle the remaining two events. So what might happen to a connected client? Well, what might happen to a connected client is that one, they might send some data, and it's a client on data. And two, they might end the connection in some fashion. Either they might end it graciously, there might be some sort of a procedure to end the connection, or the connection might be reset. So when they send some data, what I'm going to do is actually go through the list of clients, and for everybody who is not me, right, I'm going to send the data. Like I said, it's a really simple example. Something else I must handle, though, is what happens when a client disconnects. And when a client disconnects, I have to remove them from the list of clients. Now, when the client disconnects, and that's all that has happened, I'm going to get no errors. However, if I try to write to a disconnected client, I'm going to get the equivalent of writing on a closed stream, right? And I'm going to get an error because I can't do that. So I have to remove them from the list to avoid this particular happening. Okay, so this is somewhat how it works. If I'm thinking about an HTTP server, right, in Node, I can create an HTTP server. But the HTTP server is not going to, that I can create with the basic language, is not going to fit our requirements very well. Because although our applications are going to be the equivalent of writing our own servers on the backend, we're not interested in low-level stuff, right? Our backend is going to be a RESTful service. It's not going to be something which is interested in how the data is sent, for example. There is, however, a package which is called HTTP, which is going to allow us to actually write these basic HTTP servers in Node. Okay. Now, what we're going to use for this is going to be, right, so if we look here, this is a simple HTTP server. And it doesn't do much, right? It says on the request event, do something. And in this case, it just writes a response to me. Let's just see the whole code, right? It just writes a plain text response to me. Well, if I'd want to make a RESTful service on this, I'd have to now wonder what was required of me, right? I'd have to wonder, okay, so what did they request? They requested an endpoint. I have to represent the endpoint somehow. And then I have to wonder, how should I get the reply? I have to support JSON to be able to send the objectual replies and so forth. However, even with this simple server, we can actually test it and see how it works. So it's a test node. Okay, so I started my server, and now if I want to test it, I just have to connect to it. So I'm going to go to localhost 8080. Right, and it says got it. That's all it knows how to do. Now if I request something else, it doesn't know what to do. Right. It does one thing. It replies to everything in the same fashion. Any more complex behavior I have to implement by myself. So I'm going to need something more complex, and let's see something more complex. I'm going to use Express. Now the idea with Express is going to be that it's going to be an external library. Right? So because it's going to be an external library, I have to manage the dependencies somehow. The way I manage the dependency is that I have it here in package.json. Now, I think we have to compare this to something like Maven. Did you use Maven in Java? Well, the advantage of Maven? No, okay. You should get familiar with Maven in Java. Maven is the dependency management mechanism, one of probably the most popular dependency management mechanism which you have in Java. However, Maven is actually something which manages the life cycle of a project. So it's going to force you within the constraints of an artifact, right? It has to look a certain way. It has to do certain things. The advantage that I see in NPM is that although I can implement stuff which have project lifecycle components like testing, running tests, deploying, etc., I can elect not to do it, right? So I can start with a really simple structure like this. I just use it for dependency management, and I can elect not to do it. And in order to see how useful this is, based on this, we've had this node modules directory created. And when I install Express, I might have a simplified vision over what happened. But Express is a web framework. And the web framework is going to have a lot of dependencies itself. Okay? And the dependencies are going to have a lot of dependencies themselves. And I'm going to have a dependency depth which is huge. And each of these has a version. Right? Each of these has a version. And this wouldn't work unless I have everything in place. And I can actually do it really simply in the sense that if you have my package.json, you can just run npm install and everything is going to be done automatically. This is not interesting for now. So it's all really simple, a really simple web application, right? The really simple web application was this. And what it does is it includes Express, it creates an Express app, and then it says for a particular endpoint, which is going to be a combination of method and address, it's going to have a particular behavior. Well, let's look at this line because this is the line which is relevant. And it says this. I have on my Express application, I have this method which is called get. What get knows how to do is handle get request. What it doesn't know how to do is what behavior I want to have there, right? What I'm supposed to do for the get request. However, there's a lot of boilerplate stuff which must be done. For example, the request when I received it was a bunch of text, right? And it would be useful to have something interpret that bunch of text to understand what the headers are, right? To understand what parameters I received and so forth. Now, obviously, this doesn't come into play in my example because it's a really simplified example, but we're going to see it later. So what I'm going to do is send my behavior as an anonymous function. It's an arrow function, and it's an arrow function which is of request and response. I need the request in order to know what was required of me, right? What was requested, what parameters, what headers, everything. And I need the response to have an abstraction to be able to write to the client, to write the response. Now that being said, whenever I say response.send or something equivalent, I'm losing control, right? So I can't do anything else with the response after I've sent it. It does make a bit of sense. Now before continuing with our examples, let's go back to our presentation and talk a bit about web applications. Right. This is the discussion about Node, but we've covered it in the example. So everything is event-focused by default. And what's going to happen is that operations in Node are going to be non-blocking, right? They're going to be run asynchronously. This solves the problem, but creates a problem. If you think about synchronous operations, it's sufficient to think about a more classically designed graphical user interface, because that's how JavaScript started, as a language to automate a graphical user interface. And if you think about a Windows Form application, and you click on a button, and on the button you have a long-running thing, something like a web request. What's going to happen to the interface? Any idea? Well, it's going to stop responding. It's supposed to repaint continuously, and I did something which is blocking, right? I basically asked the program to wait for something. And while it's waiting, it can't repaint. Now, when JavaScript was designed, this was probably taken into account. And what I can do is treat everything which is long-running as asynchronous. And then I can repaint. However, I no longer have the classic mechanism of waiting for my result. I have to have something else. And one way of doing it is with events. Now, obviously, Node.js, which is the server-side JavaScript, was created a long time after that. However, it still maintains the general vision of JavaScript. It's the same language, right? So wherever I'm going to encounter JavaScript, I'm going to encounter in an event path, for example. I'm going to have events. So this is my simple server. Now, talking about web architectures. So the idea is I'm going to want to have an application on the web. How am I going to organize it? Because we've already talked about how web applications were imagined initially. And initially, I would have gotten an HTML, which had a form in it, and the form would have had a method and an action. And the user would have completed the fields in the form, pressed the submit button, the form would have been unpacked in some fashion, and sent to the to something to interpret this, which would have been a CGI. And the CGI would have produced my next page as its output of sorts. Right? I would have gotten something, a page which was dependent on the CGI's output. Now, obviously, this is not a very flexible approach. And the first addition to this was the initial PHP thing, right? Where you could write web applications by mixing HTML code and scriptlets. This is also not quite maintainable. So, historically speaking, web frameworks started to appear. So these are, on one hand, there are libraries which are designed to help you write web applications, but they actually also force you onto a certain approach, which is considered favored. So I'm going to have web frameworks, historically I'm going to have web frameworks which are server-side focused, and I'm now going to have web frameworks which are basically client-side focused. So I can, when I talk about writing applications which are primarily server-side, they're going to work in the following fashion. The client is going to see in their browser only JavaScript, HTML, and CSS, because that's what the browser knows. However, the structure on the server is going to be more complex. And I can organize things on the server in two particular general approaches. One is to have a framework which is request-focused, which tends to not hide the mechanism of HTTP very much and give me access to what is happening. However, it doesn't have anything which will allow large-scale component reuse. And the request-based frameworks are going to talk in terms of interceptors generally, because I want more complex behavior. And what I'm going to do, I'm going to have the fiction that I have an entity which intercepts the request from the user, rewrites it or processes it somehow, and then forwards it to me. Conversely, I'm going to have outgoing interceptors, which are going to rewrite the answer I'm trying to give to the client. So this is really close to the bare bones of the protocol, and it allows me very much control, but it's not that much reusable. So there was this the second approach, which was the component-based architectures. And component-based architectures on the server side include stuff like JSF, Java Server Faces, stuff like classic ASP.NET, and so forth. Now, this has the advantage that I can actually write complex components. So I can have something which is, for example, represents a grid, or a complex table, or a tree. But how can I have it? Well, what's going to happen is that the user in their browser is still going to have some forms with some actions. However, when they invoke these actions, the server is going to have kept in its memory a component tree, so a representation of my interface. And it's going to take the value I've sent and see if it needs to copy them somewhere in the component tree. Right? So if I change the value of a text input, there's going to be a node somewhere which represents the text input, and assuming it passes validation and everything, is going to be copied in that node. So how do I get what I see in the browser? Well, the server is going to have a rendering mechanism. And the rendering mechanism is going to take the component tree and produce HTML, JavaScript, and CSS. Now, the defect to this approach is more evident in some cases and less evident in some other. But the idea is that what I'm writing in my source code is really different from what the user is executing in their browser. Right? It's something else. I'm writing in terms of components, and they're seeing HTML code. And if something breaks, the failure cycle is very long. Right? It's the part where it breaks is not directly connected to the part which I've written. Now this is a little bit less obvious in something like JSF. It's obvious only in the fact that my components are going to have IDs which are non-intuitive. They're going to be something like JDT underscore something. But if you look at the actual generated code for something like classic ASP.NET, you're going to see that it's HTML code which nobody would have written, right? It's very happy to use iframes, and it's something nightmarishly bizarre, right? Now this is not a problem as long as everything goes according to plan. But this is software, and things don't generally go according to plan, right? Initially, they go very much not according to plan, and we correct it until we get something which is useful. So this is the defect of this component-based architecture on the server. Now, after a particular point, people realize that I can actually, instead of doing this classical flow in which I send the form and get a new page and reload it in the browser, I can actually do HTTP requests from JavaScript, and I can actually load a single page for multiple things. And these are asynchronous architectures. Now, initially, if I want to write something reasonably simple, this is going to work in a reasonably intuitive fashion. However, the more complex things I try to write in the same page, the more I'm going to realize that I need something to organize my code, right? Because if I write something which is an interface which looks like Google, ignoring all the other stuff Google does, if I write my own search engine, for better or worse, this is going to be a reasonably simple interface, right? And I can have all my code there and done in vanilla JavaScript, and that's it. However, if I write something like Google Drive, now Google Drive already has a bunch of identifiable components, and if I don't represent them somehow, the code is going to get more and more complicated, and then it's going to get more and harder to maintain. And when talking about application level languages, this is a fundamental concern, which is how easy I'm going to be able to maintain my code, because my code is going to be significantly more complex. Okay, now if I want to organize my code, I'm going to have two fundamental approaches, which are not as clearly defined though. One of them is components on the client, which is what we're going to use this year, because we're going to use React. Now, as it stands, components on the client, at least when talking about the popular mainstream technologies, still has one defect, which is that they're not actually written in JavaScript. They're written in an extension of JavaScript. All of them are written in extensions of JavaScript. And these extensions actually have to be transpiled, which is they have to be translated to JavaScript, to plain JavaScript. Because considering the extension for React, that particular extension doesn't make sense as is for the browser. For Angular 2, which is also allowed for your project, it's going to be even more egregious than that, right? I'm going to have an extension which is going to have even more features. It's going to be even harder to relate it to regular JavaScript. So I'm going to have this transpilation, and as long as transpilation exists, I'm going to have a defect which is similar to what I had on the server-side component-based architectures, right? Because I'm writing something, but what's in the browser is slightly different. And this is going to increase the length of my failure cycle. The second general approach is something which is called, includes MVC-like models. To give you an example, Angular sincerely called itself model view whatever. Because the idea of MVC doesn't actually quite fit in an asynchronous environment. So it doesn't quite fit what you do on the client. MVC is an old pattern, which was first used in Smalltalk. Right? So it's from before. It's from an age from before. It's from before the web, for example. Right? So it doesn't quite fit. So I have to have some variations on it. Now, the problem here is that I'm going to have organized code, which is going to run directly in the browser, for Angular at least, Angular 1X. However, my code is not going to be that reusable. I'm going to have to rewrite stuff which is similar. There's also another problem with Angular, at least with Angular 1X, which is that Angular 1X wanted stuff that JavaScript didn't have. They needed language features that JavaScript didn't have. And that leads to some code which looks fairly bizarre, although it is possible to understand it, of course. Let me just show you an example. I'm going to find it here. I think the examples are still on my website, so you can look over them if you're interested. But we just want to see something demonstrative, right? We're not really interested in the details. We're interested, for example, in this syntax. Right, this syntax, right? Look at it here. So I might wonder, what is this stuff? Why is it here? Why does it look like that? It doesn't necessarily look exactly intuitive, right? Well, the answer is that it's a replacement for the idea of function decorators. Function decorators are something which exists, for example, in Python, and they look like this. And they're basically functions which receive as a parameter another function, modify it, and return it. Let's see an example. We have to find it here. Right, it's something like this, right? And it's reasonably elegant. So if, for example, the function would have some parameters, and I have to ensure that they're defined. I want to inject values into the parameters. I'd be able to do it really elegantly in something like Python, but I wouldn't have in JavaScript. And they felt they needed this mechanism, and we get this. And this looks positively unfriendly. However, the advantages of the framework were bigger than the disadvantages. That being said, Angular 1x obviously wasn't the only way of doing this. This is the blessing and the curse of the JavaScript, the JavaScript community, if you want. There's a lot of competition, so I have a lot of alternatives for the same thing. This is a blessing because competition stimulates creativity, and the curse because there was this quote on the internet that to be a front-end developer, you're going to spend 60% of your time learning new stuff and 40% being productive, right? Because they evolve so quickly. And it's hard to say which are better and which are worse. The reasons that we've selected React, like I said, were market penetration and the size of the community. We wanted something which is industrially viable. Now, apart from this discussion, right, about applications which can be used as a single page, right? A single page application is just going to load a single page, and everything else is going to be done via JavaScript. We have some connected things which we must discuss. So the first thing, we've already hinted to it, it's the idea of transpilation. And transpilation is going to mean the fact that let's see some React code, and we're going to see something strange, reasonably strange. I think I have it in C9, which is the fact that in React I'm going to have structures which are not quite JavaScript. The advantage of React is that they're not quite JavaScript, but they're close. They're almost JavaScript. As opposed to Angular, where I have something which is not quite JavaScript, but it's a bit further off. One sec. We'll just load this. Close. Right. So I'm going to get stuff which is like this, right? Which sort of looks like JavaScript, right, with the class syntax. However, I get stuff like this. I couldn't say what that is, right? It's not a JavaScript thing. And what's going to happen is that some mechanism in my build mechanism is actually going to create something which is loaded in the browser. This is actually something which is minified too, so it looks horrible. But it's actually, I can create valid JavaScript without making it horrible. The idea for this, what would be the idea for this? Why would I minify something? Well, the idea is that on one hand, it might serve as a way of obfuscating things, but on the other, it's the fact that I want to send as little as possible over the internet. And by obfuscating it, I actually get something which is smaller. Because I'm going to replace all symbols with symbols of minimal size. Right? It's going to work like compression. I'm going to look at my symbols and see, okay, this symbol appears the most times. What can I replace it with, which is of lesser size? And I get this horrible thing. Okay, so this is the idea of transpilation. The second idea is the fact that I can use web applications in some fashion on other platforms. So it's not that I can use JavaScript applications, but I can use web applications, right? And this is going to work like this. First of all, we have to look over hybrid mobile apps. So what hybrid mobile apps are going to be is web applications which run as native applications. How does that work? Well, each of the major platforms, actually in their component list, has a component which is a web view. So it's a component which is capable of rendering HTML, of running JavaScript, and of rendering HTML and CSS. So I can make a shell of a native application which just contains a web view, have some JavaScript code which runs in that web view, and give the native application the permissions it needs, because it might need something which is not in the purview of web applications, right? It might need to access files or stuff like that. And I can use, there are a lot of variants here too. I've actually used Cordova, right? And I get some advantages and some disadvantages. The main advantage is that I'm going to use one app for all platforms. And more importantly, I'm going to maintain one app for all platforms, written in one language. The disadvantage is that I'm going to have an application which is going to be less efficient from a performance standpoint than a native application. So I'm going to have to figure what kind of application am I writing, right? Am I writing a dashboard for my smart home? Then I can write it as a hybrid application, because that dashboard is not going to stress my Uber phone, right? The phone which is a computer in my pocket. Am I writing a game? Well, a game has to be a lot closer to the maximum capacity of the machine. So I'm not going to be able to do it as a hybrid app, right? But for the kind of applications we're writing, we can write hybrid apps and use them as mobile. Now, the evolution of this concept is something which is installable web apps, which is web applications, just web applications without being in any container, which can actually be installed on your phone. The mechanism behind this, we're probably going to talk about service workers and stuff like that in the future. But the idea is that I'm going to be able to have an application which sort of auto-updates and which controls what traffic it does over the network. Right? So in an extreme case, I might have an application which can run completely without actually communicating over the network. So it runs like a native app. It was just installed over the network. Okay, now let's look over a couple more things. We've already talked about classical architectures and so forth. We've explained what's happening there. You can look over this stuff. Let's look over some more examples and see what we can understand. So we have this really simple thing, right, which was the simplest Express HTTP application which we could have built. Now, if we're writing classical applications, the multi-page applications, we're going to run into something which is the fundamental problem or the fundamental limitation of HTTP, which is the fact that HTTP was designed to be stateless, right? If I think about the typical case, let's say I have a web shop and I have a shopping cart. I can't actually imagine this if the application is stateless without if I have no means of maintaining state. Because think about it. You click on a product, you say add to cart, you go to a new page, the cart disappeared. Right? So I've done nothing. I haven't accomplished anything. So I have to have some way of maintaining state. And traditionally, the way of maintaining state was either via cookies or sessions. Right? And we'd be interested in seeing this code in an Express application. So if I look at my package JSON, I'm going to have Express session, which is going to allow me to keep sessions, and something which is called Pug. Well, now, what Pug is going to be a rendering engine. Because think about it. If Express gives me HTML, the way it's going to function is that it's going to have some templates which, coupled with some data, are going to give me some renderable HTML. Make sense? Right, so I have a template which says, for example, if I have a product details page. The product details page always looks the same, but what differs is the elements which are specific to a particular product. So I have a template, and then the data for the product. Okay, so let's look at our server. The server now we're going to see a couple of interesting things. This is a setting for my Express application, and it says that its view engine, the way I'm handling templates, is going to be Pug. Then I'm going to have app used, and it's going to be the session, which is going to be password protected with a really secret. But it's interesting what use does. Well, what use does is actually make my application include something which is called a middleware, but which works very much like the interceptors I was talking about earlier. So a middleware is going to intercept the response before it gets to me, the request before it gets to me, or the response before it gets to the client. And it's going to do some processing. The simplest example is that we might do logging, right? We might log each request somewhere. And every time a request comes, it first passes to the logging middleware, which stores the idea that the request has been made in a log. And then it forwards it to the relevant endpoint to do the actual processing. Okay, so what we want to see here is how we maintain state. And I have the endpoint which looks like in the past. It's get on Splash. And then I have another endpoint which is called next. And I noticed something, that inside the processing part, I'm actually getting the session by saying request.session. Now, whenever I get this session in my conversation with a particular user, it's going to be the same session. Now, the way this works is that the user is going to keep a session key and is going to send it via a header to me whenever they make a request. Okay, now the rendering part works like this. I'm going to say, instead of saying response send, it's going to say response render. And the response render is going to receive a template name and a list of key value pairs corresponding to what I want to populate the template with. If I look at the templates, they're going to be in this particular directory, which is going to be views. And let's look at this. This looks like very Python-like, right? It's white space is actually signifies a block. And I see that I can write the stuff which I could write in HTML, right? So it's the HTML tag, and this is a block, so it's going to be closed at the end of the block, the head tag, etc. But I see that for some of them, I have something which is title equal. And if I would have said title space title, that would have made the title be just the word title. But if I said title equals space title, this is going to evaluate something. So it's going to be the value which would have been in the title key, right, which I have here, title, some title. Okay, and apart from these things, I have a link, and the link is going to have a parenthesis syntax to specify attributes, and in this case, I have to specify an href. Now, Express actually knows how to use more than one rendering engine, so this is incidental. Right? We were just trying to build a simple example, and the simplest example was on the preferred rendering engine. But I do have rendering engines which look like HTML, more similar to HTML. Now let's see this working. Right, this is going to be classic. And if we now connect to our application, if we connect to this, we're going to get a 404. We've requested something that the server doesn't know how to deliver. Now, as a principle, since we're writing our web applications in this approach, like we're writing our own servers, they're only going to know what we tell them to do, right? If we define some endpoints, those are going to be valid. Everything else is going to be non-defined. It's going to be, you've requested something which I don't know how to deliver. A client error, 404, not found. So let's go to the root, because that was the interesting part. And I see that the title is some title. So I rendered this particular template. And there's a heading which says some message. And if I press next one, I'm going to see something with random stuff. Now this is important because I've actually set random stuff on the previous endpoint. See, session data, some data is random stuff. But I can actually access it here. And this is maintaining state. Make sense? Now, do you have any questions until now? Okay. Now let's see an evolution of this. And I was giving you the example with the shopping cart. Let's see a shopping cart, which is going to be really similar. Obviously, it's not. We're not going to look over a full shop now. We're going to just look over something simple. And it's shop. And let's first look at it work. Let's see what we can expect. So we don't get our hopes up. Like I said, it's a really simple thing. And this time, what's going to happen is I'm going to get here, and I can see my cart and my list of things. And I see the cart actually adds a number of things. We can easily extend this. We could actually make a minimal shop with relatively little effort, but we're not interested in that. We just wanted to demonstrate the mechanism. So how does this differ? Let's see. Well, I still have the view engine. I still have the session thing. Since I don't want to have any storage for now, we're going to discuss it in a future course. Since I don't want to have the storage for now, I'm going to cheat. And I'm going to use something which is called app locals, which are local variables to the server. And the idea of app locals is that they're going to be accessible at server level. So for any user, they're going to have one value right there. They're application level variables. Now, of course, if I close the server, I'm going to lose them, which is why I would have needed persistence. So I have a product here, right? This is my product. I'm actually not using the image, but I could have. So what's going to happen is that when I request the root, the slash, I'm going to get the session and create a session cart, which is going to be an empty array initially. Then I'm going to render the index by giving it a list of products and whatever's in the cart. Now, if I look at my application, this add button is going to be dependent on a particular product. If I have more than one product, I'm going to need to send which product am I referring to, right? We can actually change this a bit so we can see what's happening. Let's add another product. This is going to be 2, and it's going to be BBB, and the rest is irrelevant. Let's relaunch our server. Get back to our app. We're gonna see what? Oh no, it's sorry, it's not quite cleanly written. We're gonna see 2 products, right? I don't know why it's written like this. Right, so I'm going to have to know to which product am I referring. Right? Okay, which means that my endpoint is going to be have to have a parameter. And let's look at our endpoint. It's /add/ something ID, right? Okay. Now, actually, I can now see what get was doing for me. And what get was doing for me, the get method of the app, was actually giving me this. I can say request.params.id. It understood what the ID is, right? It parsed the URL and it understood where the ID came. This is just an alias, right? I don't have to write ID or anything else. It's a symbol which I then replace and I can access it. And then I wonder like this: does the product exist? Now, obviously, our app is not written exactly cleanly because it's not complete. However, this gives us the opportunity to talk about something, which is that I have to consider the user as being hostile. right? I always have to wonder if the user is trying to, in the web environment, if the user is trying to circumvent whatever I put in place to give me invalid requests, for example. So I gave them an interface in which they pressed a button next to a product and it sent the ID that I had on that line. However, what they're going to do is get the postman out, right, and make a request which tries to add something which is invalid, a product which doesn't exist, just to see if it works. Which means that I have to have a reasonable amount of validation on the server from an data integrity standpoint. Any validation which I do on the client is going to also be useful, but it's going to be an ease of use thing. Right? It's going to be a discussion about ease of use. It's just going to tell the client more easily what they've done wrong. But it's not going to be a data integrity concern, because the client can circumvent anything that's on the client and get behind it and try to see what's going to break. Now, this part of the logic says, obviously we've used filter, which is a method, an array, which allows us to just get the elements on the array which respect the condition. And in this case, for example, the product list, right? If I filter products, what I'm going to get is either one element or none, right? Either one element because they're theoretically unique, or none if it was a product which was invalid. Now, on the session, we're also going to do a filter. And the idea is that if the product existed in the cart, I'm just going to increment its count. Right? If you had one pair of shoes, I'm going to, and you click add again, you're going to get two pairs of shoes instead of just getting duplicates of the same thing. If it doesn't, it's going to be added with a count of 1. And I noticed something really interesting, which is that I don't need something special for the structure of the cart. I can just decorate my product with an additional property. I just said p.count equals 1. Because we're in JavaScript and we can modify the structure of objects at runtime. Okay, I add it to the cart and then I render again. So this would be a classic application. Now, we're also going to look over an application which is the simplified version of what we're going to go. And this is going to be an application which is going to be a single page app, but it's a single page app which is written in the monolithic fashion, right? So it's a single page app which is going to have no way of organizing code, and it's done in vanilla JavaScript with one exception. And we're going to see what it does. Right, so it's this API example. Right. So if I look inside my API, let's ignore a couple of things. My API is really simple, right? And let's ignore this part for now. So my API is going to reply with JSON, with objects in JSON, or it's going to consume objects in JSON whenever I request something of it. Let me just restart this. Now, I have some widgets, and I've hard-coded the widget here. So let's first request a widget. So we're going to go here, and we're going to say localhost on port 8080/widget. And we're going to get a list of widgets. Right. Awesome. Now my API could be used from a large spectrum of possible types of applications. However, it could be used just like this. And my only problem with my API now is that in order to test it, I have to have something else, and we're going to launch a Postman. And my API is also going to know how to add widgets. Let's wait for it to start. Now, something to note here is that we had to do something for our API to work. Right? We can post to it, so we're going to post to localhost widget. I don't know how well you can see that. I think you can. We can post to localhost widget. However, we have to do some stuff in addition to what we were doing for get. In the body, we're going to have a widget. It's a new widget. We're going to add a new widget. And we have to have a header, which is going to say content type application JSON, right? In order for our API to know what it's supposed to receive. So we're going to do this. We're going to see it says added. And then if I get the widgets again, we're going to see that we have our new widget. Okay, so our API works. Now, how does it work? Let's look at it. Now, what's happened is that, we still have our state in our app locals, and we have two endpoints, get widgets and post widgets. Now, get widgets, intuitively, even if I didn't know what was written in it, I'd expect it to give me a list of the widgets in whatever format the service uses, in this case JSON. And I see that I have a method, which is another form of send, which is going to send stuff as JSON. And it's I can't actually have an error in my case, and I always say 200, and I send app locals widget. Now, if we had persistence, we would have had multiple branches, right? Because we might have had an error. For example, I might want to query a database, and the database might not respond. And then I'm going to give an error to the client. In our case, since we're taking it from the local state, if the server can reply to anything, it can't have an error. Now, for post, what we're going to do is just app locals widgets push request.body. But this is interesting because why is request.body a JavaScript object? Well, the answer is that we used an interceptor, a middleware, which is body parser. And in order for it to apply, we've said app use body parser.json. Now, this is actually somewhat of a strange solution because JSON is really close to the representation of JavaScript objects themselves. And I just figured that given a bit of text, which was the text corresponding to a JSON object, JavaScript would have known how to interpret it. And it's reasonably easy. However, what the makers of Express decided is to couple all the interpretation mechanisms in one thing. And body parser actually can interpret objects from XML, from URL encoding, etc. And although it doesn't seem really that natural for JSON, it's natural in the grander scheme of things. So I have the object in request.body, which is why it works. So I can't fail on this either, because I just added to an array. So I'm going to say that it's okay, and I say added. Okay, so I have an API. Now I might want an app too. Now let's see the app. Now, what I've also added is another middleware, which does the following. Now, I said that my API actually only replies to the stuff which I've explicitly defined. So get widgets, post widgets, and that's it. The rest is 404. What Express Static does is before sending an error to the client, it wonders if the client might have actually requested a static resource. And it looks in that directory, which is called app, for a static resource corresponding to the request. And if such a resource exists, it gives the resource. Right, so now our application actually also functions like a traditional web server. Now there's one resource here which is index. Now let's see what happens. So we're just going to go to if we go to something, we're going to get a 404. If, however, we go to the root, we're actually, one sec because I didn't relaunch my server and it doesn't dynamically load. If we go to the root, we're going to get this. What happened was that when requesting slash, I didn't have an explicitly defined endpoint. And then the server actually wondered if it could give me a static resource. And there's a convention at play here, which is that if I request a directory, it's going to actually consider that I requested an index.html file in that directory. So in slash, and my root is saved in that app thing on my hard drive. See, it's actually, I said that my web root is actually this app directory. This is where static resources are given from. I've just configured it. And it gives me this stuff. Let's see if it works. So test. Right, so the page doesn't reload, and this happens. So it's added something on the server, it's reloaded, etc. Let's look at it and see how it functions. Well, how it functions is that I've actually got some plain old JavaScript here, which is going to do my logic. Let's make it more compressed. I initially wanted to write this just in vanilla JavaScript, but the way we make HTTP requests in vanilla JavaScript is a bit less comfortable, which is why I used Axios, which is something to do HTTP requests with, which is promise aware and so forth. So let's look at our structure first. So our structure is this. I have a form. I'm interested in the IDs because I'm going to manipulate everything from JavaScript. And I have a table which is empty. Right, so when my application starts, it first loads the DOM, and after it loads it, it's going to fire an event which is going to be window.onload. And in my handler for this event, I'm going to have my init function called. Right, see it here. And the init is going to request all widgets, and I'm going to have one of two possible outcomes. One outcome is that I get the widget, my request was processed correctly by the server, and the other was that I had an error, right? And we're going to tell the user that our trusty hamster is running into trouble, because that's how the internet works, right? There's a hamster which runs to the server and gets the response for you. Now this is another interesting point. You should only expose error messages to the user for which the user can have a solution, right? If they can do something to fix it, fine. If they can't, they need to know. It's just a generic error. Okay, so if I got a response, I've presumably read the documentation for the library, and I know that the actual response text is in response.data. I have to look at the documentation. I can't guess it. Now, what we're going to do here, let's think about it. What we're going to get is an array of objects which are represented represented in JSON. What I need is for each line, for each element of this array, to get a row in my table. Right? So I'm going to use map. I'm going to say data map. So for each element, I'm going to get a row. And I know that the structure has a name and a type. And I'm just concatenating some strings. Okay, so after this step, what I get is an array of strings representing what the rows should be, right? But what I actually need is one string with everything. So I'm going to reduce this in a fashion which is similar to making the sum of the elements of a vector. And I'm going to get just one big concatenated string. Now, since I'm in a really simple example, what I can do is get element by ID for my table, which is this table, and just replace its content, inner HTML, with my content. Okay, so what's going to happen if I click on the add button? Well, I've added a listener to the add button. This is a simplified way of handling events. And I've just put an arrow function in the onClick property. And the way it's going to work is that I'm going to send something to the server. What is this something? Well, this something, my payload, is going to be an object which has the keys name and type, because that's how widgets look. And the values are going to be taken from the corresponding text input. The reason why this works is that the value property on the object behind the actual tag is going to contain the current value, right? So it's the value that the user input. Okay, so I'm going to post the payload to localhost widgets, and when if I get a successful response, I'm going to run init again. The reason why I'm doing this instead of manipulating the table I already have is that, for example, if I add multiple widgets and I see if I get a correct response, I just add it to my table instead of reloading stuff from the server, is that web applications are usually useful when I have to have coordination between users. So I'd assume that more than one person can add widgets. And whenever I don't load after I do an operation, I'm becoming more and more disconnected from the actual server state, right? Because somebody else might have added a widget. Okay, so this would be a simple application in the vein of what we're writing here. What we're going to write here after this initial step is going to be a bit more complex because we're going to organize our code. And we've already seen something which is React-like, but we don't have enough time to actually discuss how React works. Let's see if we have anything which we've skipped. Yeah. Now, there's something which we're going to discuss in the future course, but we can discuss in principle now, which is how do I access data? If I look at how applications with database access used to be written 20 years ago, I would have had a way to run SQL on the database. Now, this actually has evolved in time, and the way that modern applications are written is they're written with an abstraction layer. Now, this abstraction layer has appeared when thinking about applications which store data in relational databases. This is because relational databases represent stuff in a way that no other thing represents stuff, right? There's nothing which corresponds to varchar actually, which is a variable length string. There's if you think about a foreign key, a foreign key is going to be from a child to a parent. But if I think about how I'd represent this in an objectual language, how would this look? Well, the relationship would be inverted, right? It's the parent would contain a list of children, right? So things don't actually match. If I think about objectual specific things like inheritance, how do I do inheritance? If I store an object which is inherited which has a number of inherited characteristics from the type, how would I store that? And in order to get more maintainable code, APIs which are called ORMs were used, which are object relational mappers. And the way that we work with relational databases is via an ORM. And this is the way we do this in any language. Right? We have Entity Framework in C#, we have Hibernate in Java, we have Sequelize in Node. We're going to use Sequelize. Now, something which must be noted is that not all databases are relational. However, access to non-relational databases is also going to be done in principle via an abstraction framework. Now, the discussion is relevant for Node because there's a database, a NoSQL database, which actually has an interface in JavaScript and stores stuff in JavaScript-like structures. And this makes it a really good candidate for storing JavaScript, for storing the data I need to manipulate in Node. And I'm going to give you just some examples for this. We're not going to do either our projects or our courses in this because there are a lot of relational databases. But I'm going to give you some examples at least for how things would be done in Mongoose, which is the way Node would store data over MongoDB. By the way, MongoDB is a really interesting thing. If you haven't played around with MongoDB,